As the blood flows through your arteries, it actually puts a pressure against the walls of those arteries, which is referred to as blood pressure. And you can actually feel this blood pressure as a pulse. So if you've ever watched any sort of medical drama, you would be familiar with this noise. Well, that's the sound of a ECG machine, or an electrocardiograph machine, which produces this reading here on a screen, and each of these individual peaks is a pulse. Now, another machine is used to measure blood pressure and changes in blood pressure, and it's referred to as a sphygmomanometer. No kidding. So this is how it's spelled. So I'm just going to call them blood pressure monitors because I'm not going to be able to pronounce that word again correctly. But a blood pressure monitor measures the changes in blood pressure during the cardiac cycle. And the units of measurement are in millimeters of mercury. That's how the pressure is measured. So you may have had your blood pressure taken before, and this is how it works. This is an example of an old blood pressure monitor. These days they're mostly digital and someone just presses a button. But I think this gives you a better idea of how these operate. So they place a cuff around your upper arm and inflate that cuff so you can put air into that cuff. And as it does that, it puts pressure on your upper arm and cuts off the circulation to your lower arm. And you can see that the doctor here is using a stethoscope to listen for that heartbeat and listen for that point where you can no longer hear the pulse. They then slowly release that air pressure and listen carefully for when they can first hear a pulse again. And when they first hear a pulse, they take a measurement on the blood pressure monitor in millimeters of mercury, and that's referred to as the systolic pressure. And this is actually when your ventricles in your heart are contracting. They then keep releasing the pressure in the cuff until they can no longer hear the sound of the pulse. And then they take another measurement in millimeters of mercury. And this is referred to as the diastolic pressure. And this is when ventricles are relaxed. So this is a graphical representation of how blood pressure is measured, with blood pressure in millimeters of mercury on the vertical axis and continuing pulse on the horizontal axis. So the wave shape is the varying pressure of blood through your blood vessels. The peak is when the ventricles in the heart contract. This is the point at which you have the highest pressure of blood in your blood vessels. And the low point is when the ventricles relax. That's when you have the least amount of pressure in your blood vessels. So when the cuff is inflated, it gets to a point where the pressure in the cuff is greater than the pressure of your blood to be able to push blood through your vessels, and that's why you can't actually hear that pulse. It's restricted. As you slowly release that pressure, you get to a point where the blood pressure in the body overcomes the cuff pressure, and that's the point at which you can start to hear a pulse again. If you keep releasing the pressure, you get to another point where the sound of the pulse ends. These 2 points, where you hear the pulse begin and when you hear the pulse end, are the systolic pressure and the diastolic pressure, which is measured in 2 different numbers. So in this particular case, this person's blood pressure is 120/80. So blood pressure measurements vary depending on your age and level of fitness, but this is generally a healthy range, a 120/80. So blood pressure actually decreases with distance from the heart. So the arteries have the highest blood pressure, whereas the capillaries, which are furthest away from the heart, have the lowest pressure. Now, the velocity of the blood, in other words, the speed in which it moves through your vessels, also decreases with distance from the heart. So it moves fastest in the arteries and slowest in your capillaries. And that's deliberate because it enables the capillaries to exchange materials with the interstitial fluid over a longer period of time. So you can see from this graph here that the highest blood velocity is in the arteries at this point here. It then decreases as it moves through the arterioles and finally gets to its slowest velocity when it reaches the capillaries, and then increases slightly as it goes through the venules and back to the veins. But the cross-sectional area of the vessels is actually lowest in the arteries and increases to its highest amount in the capillaries. So the capillaries have the greatest cross-sectional area of any of the vessels in your body. This means that the blood is flowing slowly through the capillaries, which have a great surface area, or the greatest amount of surface area. And this enables time for substances to transfer in and out of the interstitial fluid surrounding the capillaries. So your body actually regulates your blood pressure, and it does this in a number of different ways. In the long term, it actually changes the volume of the blood in your vessels. So it can either increase your blood volume if your pressure is too low, or it can decrease the volume of blood if your pressure is too high. So in other words, if you increase the amount of blood you have in your vessels, it increases your blood pressure. And if you lower it, then that lowers your blood pressure. So that's a long-term solution, whereas sometimes your body needs to react much more immediately to blood pressure. And it does that through something called negative feedback. And that can work if you've got blood pressure that's too high or if you have blood pressure that's too low. So let me walk you through that. If your blood pressure is too high, what ends up happening is that you have pressure receptors in your aorta, and they send information to your brainstem. Then what happens is the arterioles in your skin dilate. They get wider, which decreases your heart rate so that you end up with normal blood pressure. Now the opposite case is when your blood pressure is too high. Again, the pressure receptors in the aorta send information to the brainstem, and what they do is they make the arterioles in your skin constrict, which increases the heart rate. So you end up with normal blood pressure. So there's actually special terms for these changes in the diameter of the arterioles, and they're referred to as vasoconstriction, which is when the blood vessels narrow, and that causes blood pressure to increase. What causes this is the muscles in the arterial wall contract. The opposite is vasodilation, and that's when the arterioles widen, when the muscle relaxes. So just remember, vasoconstriction means increased blood pressure and vasodilation means a reduction in blood pressure. So in summary, blood pressure is the force that blood exerts in the walls of arteries. Blood pressure is measured as two values: a systolic pressure, which is the pressure exerted when ventricles in the heart contract, and a diastolic pressure, which is when the ventricles relax. Blood pressure and blood velocity decreases with distance from the heart, allowing capillaries to exchange materials with the surrounding interstitial fluid in tissues. And the body regulates blood pressure in the long term through changing blood volume, or in the short term through negative feedback, causing arterioles to either constrict or dilate.